Hello, today I'd like to go over the steps to solving a Newton's second law problem and several examples to help you before you begin the practice. So there are three different steps to solving any Newton's second law of motion problem. So the first step is to read the problem and draw a free body diagram which labels all of the forces that exist on an object. The second step after drawing a free body diagram and labeling all the forces is you're going to write a net force equation for the object in both the x and y direction. The last step is going to be to write a full Newton's second law equation for the object in both the x and y direction. So it's a little confusing what these steps are, so I'm going to show you with an example down below. So there are two sign conventions that we're going to use with Newton's second law. So for our sign convention, okay, anything up is going to be positive and anything to the right is going to be positive. So if it's down or to the left, it's going to be negative, have a negative force. So here are two example problems. So I'm going to illustrate the three steps that I described below. So a book is at rest on a tabletop. So the first thing that I'm going to do is draw a free body diagram that labels all the forces that exist on the object. So since the book's at rest, we know that the forces are in equilibrium. So we're going to have gravity going down, the normal force from the surface up on the book going up, and those forces are going to be balanced because it's at rest. Okay, so once I've drawn a free body diagram, then I'm going to label or write a Newton's net force equation in both directions. So my free body diagram is step one. Step two is to write the net force equation. Okay, so there are no forces in the x direction, so I can cross that out. There's no net force in the x direction. In the y direction, my net force, so net force means the sum of all the forces in the y direction. So I have the normal force plus the force of gravity. Now, because the force of gravity is down, and we said that down, according to our sign convention, is negative, I'm going to add a negative here. Okay, so step two is to just write these two equations for net force. So the third equation, or the third step, is going to be to actually write out a Newton's second law equation for both directions. Okay, so there's no forces acting in the x direction, but in the y direction, we know that Newton's second law says that net force is equal to ma. So in the y direction, my net force is Fn plus negative Fg, and that is going to equal ma. Since the acceleration is 0, because my forces are balanced and it's at rest, I know that Fn plus negative Fg must equal 0. Therefore, Fn must equal Fg. Okay, so step one, draw a free body diagram. Step two, write a net force equation in both directions. Net force just means adding up all the forces that exist. And the third step being actually applying that to Newton's second law, which is F equals ma, or net force equals ma. So I'm just subbing in my net force and having it equal ma. So here's the second problem I'm going to do. Try one more. This one will be a little more complicated because it has forces going in both directions. So the first thing I'm going to do is draw a free body diagram. So a rightward force is applied to a book to move it across the desk with a rightward acceleration. Consider frictional forces, neglect air resistance. So I know I have the force of gravity down. I have the normal force going up from the surface up on the book. It has a rightward acceleration by a rightward force. So I have an applied force to the right, and we're considering frictional forces, so I have friction going to the left. I know that this object is not accelerating up and down, that those forces must be balanced, the normal force and gravity. Okay? Because it has a rightward acceleration, I know the force applied is going to be bigger than the frictional force. So the first step is to draw the free body diagram. The second step is to make a net force equation in both the x and the y direction. So net means sum all forces. So in the x direction, my forces are applied plus friction, and friction is negative. In the y direction, my forces are the normal force plus gravity, and gravity is negative. My third step is going to have these work on Newton's second law. So we know that Newton's second law is F equals the sum of F equals ma. Okay, so in the x direction, I have my net force is Fa plus negative Ff equals ma. Now it is accelerating in the x direction. It says it has a rightward acceleration, so I'm going to leave that as is. Okay, in the y direction, I know it's Fn plus negative Fg, and I know my acceleration in the y direction is 0. So I know Fn must equal Fg in the y direction because there's no acceleration. Okay, so hopefully this will help give you an idea of how to start the practice. Okay, but you're following these 3 steps: drawing the free body diagram, summing up all the forces in each direction, the x and the y direction, and then making a Newton's second law equation in both directions.